Part 3, Graphing Piecewise Defined Functions. Here we have a piecewise defined function. F of x equals absolute value of x if x is less than or equal to -2. F of x equals 3 if -2 is less than x is less than 1. And f of x equals 4 minus x if x is greater than or equal to 1. So we're going to graph this in 3 pieces. This is why it's called a piecewise function, because there are different pieces of this graph. So here's the graph of the absolute value of x. Now we only want the absolute value of x where x is less than or equal to -2. So here's -2. We only want where x is less than or equal to -2. So to graph that part, I am going to look at the boundary, -2. When x is -2, the absolute value of -2 is 2. So that's a point -2, 2. And I'll put that on my graph, and I'm going to use a solid dot because it says x is less than or equal to -2. If it was just less than, I would use an open dot. Now I know what the rest of the graph looks like to the left here, so I'll draw that, put my arrow because it keeps going. So this is everywhere x is less than or equal to -2. Now for the middle part of the graph. This is the graph of f of x equals 3. It's a horizontal line where y is 3, but I only want this between -2 and 1. So -2, and then we're going to keep going up until we get to where x is 1. So we only want the part between -2 and 1, which we look at this graph is just this part right here. So just that little part. And we're going to use open dots on that because we have less than, not less than or equal to. So -2, less than x, less than 1, not a less than or equal to. So I'll use open dots for the endpoints of that part. Now the last one, 4 minus x. So here's the graph of 4 minus x. We only want this graph where x is greater than or equal to 1. So here's our x is 1, and we want where x is greater than or equal to 1. So if I substitute 1 into that equation, 4 minus 1 is 3. So we have a point at 1, 3. And because it says greater than or equal to, we need a solid dot. So I'm going to fill in that dot at 1, 3. And then we have the slope of -1. And we have something like that. Let's look at this function and try to write the definition for the piecewise function here. So we're going to use our toolkit functions. So the first part on the left, our domain of the first part would be everywhere where x is less than or equal to 1. And I know that because this first section toward the left, we have a closed dot where an x is 1. And then we go have the arrow on the left. So everywhere where x is less than or equal to 1. And that is the graph of x squared. We know that from our toolkit functions. The next part of the graph is right here, where I have x is between 1 and 2. So I'm going to have 1 less than x less than 2. And those are both open dots, so no equal to on that part of the domain. And this graph is just -2. It's a constant function at -2. Now the next part of the graph is on the right, and that starts where x is 2. So I have x is greater than or equal to 2. I have a closed dot to start there when x is 2. So it's x is greater than or equal to 2. And that function from our toolkit function is the function y equals x. So here is our piecewise function.